test a fire hydrant system after installation, you will need specific equipment and a defined procedure. The necessary equipment includes a direct current power supply capable of delivering 150 amps, an ammeter to measure current flow, 2 conductive probes or bar electrodes, insulated cables to connect the equipment, and a water source to connect to the hydrant. The test procedure involves several steps. Firstly, prepare the system. Open and flush the hydrant fully to remove any debris. Connect one probe to a ground rod or any other conductive surface near the hydrant. Connect the other probe to the discharge outlet of the hydrant. Secondly, set up the power supply and ammeter. Connect the power supply to the probes. Turn on the power supply and adjust the current output to 150 amps. Connect the ammeter in series with the power supply to monitor current flow. Thirdly, conduct the test. Allow the current to flow through the pipeline for 5 minutes. Monitor the ammeter reading continuously. The current flow should be steady and maintain the 150 amp level throughout the test. Fourthly, evaluate the results. If the current flow remains steady for 5 minutes, the electrical continuity of the pipeline is considered adequate. If the current flow drops below 150 amps or fluctuates excessively, it may indicate a defective electrical contact. Isolate and correct the cause of the defect, such as loose connections or breaks in the pipeline. Fifthly, clean up. Disconnect the equipment and remove the probes from the hydrant and ground rod. Close the hydrant and restore the system to its original condition. When performing this test, ensure that all equipment is properly grounded and operated by qualified personnel. Use personal protective equipment such as insulated gloves and safety glasses. Always refer to the manufacturer's instructions for the specific equipment being used. The key to a successful test is maintaining a steady current flow of 150 amps throughout the 5-minute duration. Any interruptions or significant fluctuations indicate a problem that needs to be addressed. Remember that insufficient current, intermittent current, or arcing, indicated by large fluctuations of the ammeter needle, signifies defective electrical contact in the pipeline. The cause must be isolated and corrected. The ammeter is a crucial tool, providing continuous monitoring of the current flow. A sudden drop or erratic movement of the needle immediately alerts you to potential issues. The probes are used to establish electrical contact with the hydrant and ground. These connections must be secure and free of corrosion to ensure accurate readings. Safety is paramount. Always use insulated gloves and safety glasses to protect against electrical hazards and water spray. It is also essential to follow the manufacturer's instructions for the specific equipment you are using, as procedures and safety precautions may vary. This test verifies the electrical continuity of the fire hydrant system. Good electrical continuity is essential for proper operation and safety, allowing for effective grounding and preventing potential hazards. When connecting the power supply, ensure the polarity is correct. Incorrect polarity can damage the equipment or produce inaccurate results. Double-check all connections before initiating the test. If the test fails, systematically inspect all connections and components. Look for loose connections, corroded terminals, or damaged wiring. Use a multimeter to check the resistance of the pipeline segments to pinpoint the location of the fault. Before starting the test, ensure that the area around the hydrant is clear of obstructions and potential hazards. This provides a safe working environment and prevents accidents. Properly document the test results, including the date, time, location, and ammeter readings. This documentation can be valuable for future reference and maintenance. Remember to consider environmental factors. Wet conditions can affect the accuracy of the test and increase the risk of electrical shock. Perform the test under dry conditions whenever possible. If wet conditions are unavoidable, take extra precautions to protect yourself and the equipment. During the test, listen for any unusual noises, such as sparking or arcing. These noises can indicate a problem with the electrical continuity. If you hear any unusual noises, immediately stop the test and investigate the cause. After completing the test, thoroughly inspect the hydrant for any signs of damage or wear. Address any issues promptly to maintain the hydrant's functionality and safety. Regular testing and maintenance are crucial for ensuring the reliable operation of fire hydrant systems. This test helps to identify potential problems before they become serious issues. In addition to this electrical continuity test, consider performing other tests to assess the overall condition of the fire hydrant system, such as flow rate tests and pressure tests. These tests provide a comprehensive evaluation of the system's performance. When selecting the direct current power supply, choose a unit that is specifically designed for testing fire hydrant systems. Ensure that the power supply has sufficient capacity to deliver the required 150 amps. Using an undersized power supply can lead to inaccurate results. Calibrate the ammeter regularly to ensure accurate readings. A properly calibrated ammeter is essential for obtaining reliable test data. When connecting the probes, ensure that they are making good contact with the metal surfaces. Clean the surfaces with a wire brush if necessary to remove any corrosion or debris. Consider using a specialized hydrant test kit, which includes all the necessary equipment and instructions for performing the test. These kits can simplify the testing process and ensure accurate results. Remember that this test is just one component of a comprehensive fire hydrant inspection program. Regular inspections, maintenance, and testing are all essential for ensuring the reliable operation of these critical systems. If you are unsure about any aspect of the testing procedure, consult with a qualified electrician or fire protection engineer. They can provide guidance and assistance to ensure that the test is performed safely and accurately. When evaluating the test results, consider the age and condition of the fire hydrant system. Older systems may have lower electrical continuity than newer systems. Compare the test results to previous test data to identify any trends or changes in the system's performance. Document any corrective actions that are taken to address any defects or problems that are identified during the test. This documentation can be valuable for future maintenance and repairs. Consider using a data logger to automatically record the ammeter readings during the test. This can help to identify any subtle fluctuations in the current flow that might be missed by manual monitoring. Ensure that the data logger is properly calibrated and configured before starting the test. When disconnecting the equipment, follow the proper safety procedures to prevent electrical shock. Turn off the power supply and discharge any stored energy before disconnecting the probes. Store the equipment in a safe and dry location when it is not in use. This will help to prevent damage and ensure that the equipment is ready for the next test. Regularly inspect the equipment for any signs of wear or damage. Replace any damaged components promptly to prevent accidents. Consider developing a written procedure for testing fire hydrant systems. This procedure should outline the steps involved in the test, the equipment required, and the safety precautions that should be taken. Train all personnel who will be performing the test on the written procedure. This will help to ensure that the test is performed consistently and safely. Review the written procedure regularly to ensure that it is up to date and accurate. Update the procedure as necessary to reflect any changes in the equipment or testing methods. Remember that fire hydrant systems are an essential part of the fire protection infrastructure. Proper testing and maintenance are crucial for ensuring that these systems are ready to respond in the event of a fire. Prioritize safety when working with electrical equipment and water systems. Always follow the proper safety procedures and use personal protective equipment. If you are not comfortable performing the test yourself, hire a qualified professional to do it for you. This will help to ensure that the test is performed safely and accurately. When interpreting the test results, consult with a fire protection engineer or other qualified professional. They can provide guidance and assistance in determining the appropriate course of action. Consider using a geographic information system or GIS to track the location and condition of fire hydrants. This can help to streamline the testing and maintenance process. Update the GIS database regularly with the latest test results. Communicate the test results to the local fire department and other relevant stakeholders. This will help to ensure that everyone is aware of the condition of the fire hydrant system. Work with the local water utility to coordinate testing and maintenance activities. This will help to minimize disruptions to the water supply. Consider developing a public awareness campaign to educate the public about the importance of fire hydrant systems. This can help to prevent vandalism and encourage residents to report any problems with the hydrants. Support efforts to improve the fire hydrant infrastructure in your community. This can help to ensure that fire hydrants are readily available and in good working order when they are needed most. Stay informed about the latest technologies and best practices for testing and maintaining fire hydrant systems. This will help you to improve the efficiency and effectiveness of your testing program. Regularly evaluate your testing program to identify areas for improvement. This will help you to ensure that your testing program is meeting the needs of your community. Remember that fire hydrant systems are a valuable asset. By investing in proper testing and maintenance, you can help to protect your community from the devastating effects of fire. Consider implementing a preventative maintenance program for fire hydrants. This program should include regular inspections, lubrication, and other maintenance tasks. A well-maintained fire hydrant system is more likely to perform reliably in the event of a fire. Work with local businesses and organizations to promote fire safety awareness. This can help to reduce the risk of fires and protect lives and property. Support efforts to educate children about fire safety. This will help to create a generation of fire-safe citizens. Regularly review and update your fire safety plans. This will help you to ensure that you are prepared for a fire emergency. Practice your fire safety plans regularly. This will help you to ensure that everyone knows what to do in the event of a fire. Invest in fire suppression equipment, such as fire extinguishers and sprinkler systems. This can help to control fires and prevent them from spreading. Support efforts to improve building code and fire safety regulations. This will help to make buildings safer for occupants and firefighters. Work with local officials to develop a comprehensive fire protection strategy. This strategy should address all aspects of fire safety, from prevention to suppression. Remember that fire safety is everyone's responsibility. By working together, we can create a safer community for all. Ensure that all fire hydrants are clearly visible and accessible. Remove any obstructions that may block access to the hydrants. Regularly inspect the area around the hydrants for any potential hazards, such as overgrown vegetation or debris. Consider installing reflective markers to make the hydrants more visible at night. Work with the local water utility to ensure that the hydrants are properly maintained and repaired. Report any problems with the hydrants to the water utility immediately. Support efforts to modernize the fire hydrant infrastructure. This can help to improve the reliability and performance of the hydrants. Consider installing smart fire hydrants that can provide real-time data on water pressure and flow. This data can be used to improve fire suppression efforts. Work with local universities and research institutions to develop new technologies for fire protection. This can help to improve the safety and effectiveness of fire suppression efforts. Share your knowledge and expertise with others in the fire protection community. This can help to improve fire safety around the world. Remember that fire protection is a continuous process. By staying informed and taking action, we can help to protect our communities from the devastating effects of fire.